Okay. So, padayon ta. So, for this one, no, we'll try to use the D'Alembert's principle in the calculation for the equation of motion. So, as you can see here, no, we have three figures. The first one here, we have the static equilibrium. The second one, we try to apply the concept of the Newton's second law. And the third one, on the concept of the D'Alembert's principle. So, in your lower years, no, let's say you have a particle here, and then that particle is subjected to several forces. We have force 1 here, vector force 1, vector force 2, vector force 3. All is as a function of time. So it varies through time. So to obtain a static equilibrium, so we need that there should be a zero net force. So if manotice ninyo, no, the F is bold. So it means that that is a vector force. So usa sa kapamagi to write a vector force is i-bold mo siya or like this on the force or in the uh unsa ba siya nga nadla. So here we have three vector forces, 1, 2, 3, all as a function of time, and we have a static equilibrium if its net force is equal to null vector. So we have a vector force 1 function of time, vector force 2, and a vector force 3 is equal to null vector. So a null vector has a zero magnitude, no, and then it is directionless. So null vector itong tawag ani because this is a vector quantity. So we have a particle mass here, a mass with a mass m subjected to dynamic force vectors. So we obtain this, like in your lower years, is that there is a static equilibrium when the summation of all forces is equal to 0. Now, on the Newton's second law, sa may given sa Newton's second law. So Newton's second law states that the rate of change of momentum of any mass m is equal to the force acting on it. So ingon siya nga rate of change daw sa momentum of any mass is equal siya sa force acting on it. So unsa man na siya? If you remember, no, momentum P is equal to the mass times velocity. Next, we know that velocity is the first derivative of the position with respect to time. Now applying it here, no, as a vector velocity, then this is the first derivative of the vector position sa function of time with respect to time or dt. Sigun niya din nga rate of change of momentum daw. So the rate of change of momentum, so that is represented by the differential equation like this one, no, dp over dt. So we try to differentiate this one. So that we will have the derivative of the mass times the derivative of the vector position with respect as a function of time with respect to time. Or if further na nimong sulat, dp over dt is equal to, so si m or the mass is constant, ipagawas na, then we will have d squared vector r function of r of t over dt squared. Now, si uh, position na to, position vector is already derived, no? Differentiated for the second time. Therefore, this become our mass times the acceleration vector. So, kabalo mong kita nga si acceleration is the second derivative of the position. So, mana siya si rate of change ni momentum that is equal to the mass times the vector acceleration. Now, applying the concept of Newton's second law, ingon niya nga the rate of change of momentum of any mass is equal to the force acting on it. So for this example, if we sum all the forces acting on a particle, vector forces, that is just equal to the rate of change of the momentum of the mass, or simplified pag nato, the summation of all vector force acting on the particle is equal to the mass times the vector acceleration as a function of time. So mo na siya diri. Since naatay three forces nga kaakad to, we have the, so mo na siya si summation of the vector forces. Vector force 1, vector force 2, vector force 3 is equal to mass times the acceleration. So mo na siya si Newton's second law. Now, what is D'Alembert's principle? So, concept po ni D'Alembert is that, yun siya, a mass develops an inertia force in proportion to its acceleration and opposing it. So, si Newton's second law, no, iyang i-describe ang motion ni particle nga, if we have a net force here, there is a force acting on the particle, and then that force, if there is a net force, the particle will move, let's say, on this direction, and its movement will have an acceleration. And then the proportionality of constant for the summation of forces and the acceleration is the mass. So that is the second law of motion. How about in the D'Alembert's principle? Ingon siya nga, a mass develops an inertia in proportion to its acceleration and opposing it. So we have here no Fi, or the vector force I as a function of time is equal to negative mass times the vector acceleration. So sa maning Fi, we call that our inertial force. So we have here no inertia force denoted by F sub I. But since this is dynamic, we try to consider its a vector quantity. So yun siya nga, the inertia force Fi is proportional, no, to its acceleration. And then since ingon man niya opposing it, that's why we have the negative sign. So this is the inertial force. So if we try to introduce equality in this equation, then we will have our negative mass times the vector. So we have a vector inertial force equal to mass times negative mass times the vector acceleration as a function of time. So if i-apply na nato siya sa Newton's second law, so you know the forces acting on the particle, and then we have here the inertial force acting on the particle. Now, if we add the inertial force to the applied forces or applied vector forces on the particle, then we will have, if the summation of one is equal to null vector, then we will have our dynamic equilibrium. So this is a very convenient concept in structural dynamics because it permits equation of motions to be expressed as equations of dynamic equilibrium. So mano siyang concept ni dynamic equilibrium nga ang summation of all its vector forces or applied forces plus the inertia force as a function of time is equal to a null vector.